So again, first things always first, rewrite in matrix form. Okay, so that's A times X equals B, which is 5, negative 2, 6, negative 1, XY equals 12, 13. All right, so we're going to find the inverse of A. So that's 1 over something, 1 over 5 times a negative 1, that's negative 5, minus negative 2 times 6, that's going to be negative 12. And then I just flip these two, so negative 1 and 5 switch places. And these change signs. So the negative 2 becomes a positive 2, and the 6 becomes a negative 6. Now, this will be a positive. So 12 minus 5 is 7. So that's basically saying 1/7 times negative 1, 2, negative 6, 5. So my actual inverse will be negative 1/7, 2/7, negative 6/7, and 5/7. That's my inverse. Okay? Any problems up to there? Questions? Remember, the determinant is only what is underneath. Right? Now, I'm going to be using, oh, sorry, went too far off. Using the inverse method. And remember, if I'm using the inverse method, that means I'm only using the x equals a to the negative 1b. Due to when I multiply an inverse by its matrix, it becomes the identity matrix. So I have xy equals negative 1/7, 2/7, negative 6/7, 5/7 times 12, 13. So I'm just going to multiply now. So negative 1/7 times 12 is obviously negative 12/7. 2/7 times 13 is positive 26/7. Negative 6/7 times 12 is going to be negative. 6 times 2 is 12. 6 times 1 is 6 and 1 is 7 over 7. Plus 5/7 times 13. 5 times 13, I believe, is 65 over 7. So now all I'm going to need to do is to add or subtract. So 26 minus 12, since the denominator is the same, I don't need an LCM. So 26 minus 12, I believe is 14, positive 14. And then 65 minus 72. Remember, you take away the smaller from the larger, but you keep the sign of the larger. So it's like saying 72 minus 65. So that will be 7. That's it, 7, negative 7. So when I cancel out, 14 divided by 7 is 2. Negative 7 divided by 7 is negative 1. And that's my answer.